Okay. In this question, we're given that since 1980, the population of the city of Brownsville has grown according to the mathematical model, and then they give you this formula. This is the population at time t. So t is the number of years since 1980. So in this question, we're computing t in years and the population, of course, in a number of people. So it will give you like 700,000 people, you will see. Just like t is like 5 what years, you would say, not hours or days. So just at the beginning, you need to know what are the units of your exponential function, and now we can solve it. So in part A, it says explain what the numbers 720,500, the one that you see here, and the number 1.022 that you see here, what do they represent? Of course, I think all of you know this. This is p at time 0, or the initial population. And how do I know? It's because when you put t equals 0, you put 0 here, and this number, this will be 1. So it will go away. When you multiply 1 by anything, the thing remains. And so this 720,500 is the initial population. And of course, this number here, 1.022, is the growth rate. The growth rate. And notice that this is the base of the logarithm. The base of the exponential here is a equal 1.022, and this is bigger than 1, so we know that we have exponential growth. Remember this, and it will be decay if the number or the base is less than 1. Okay, so this is A. Now we go to part B. What would the population be in the year 2000 if the growth continues at the same rate? Okay, so here is the formula, and we started at 1980. So this is for us time t equals 0. So the year 2000 will be time t equal 20. So you will say, I need to replace 20 in this formula because it's 20 years later. The year 2000 is 20 years later than 1980. And so you'll get 720,500 times 1.022 to the power 20. And we need the calculator for this. So we'll do it here, 720,500 times the number is 1.022 to the power. So here we raise it to the power, and the power is t, and they ask us to put t equal 20 years. So, wow, that will be what? 1,113,000. Yeah, and then 401.7. You see 0.7, so you say 402 people. After 20 years. In the year 2000, we already... in the city of Brownsville, they will already be more than 1 million. And they tell you, use this model in part C to predict about when the population of Brownsville will double. What does it mean, will double? Well, what is it? What did we start with? We started with this number. So doubling means that this number, 720,500 times 2. So they're asking us, when would the population of Brownsville be 1,441,000? So this means that we need to solve the equation. So we're asking, when would twice of 720,500, this initial population, twice of it will be at what time? So you'll put the formula where it was what? 1 times 1.022 to the t, and we need to solve the equation for t, of course. We need to find the t that, so the time that if you replace will make the function double of the initial amount. So notice that this cancels with this, and so you'll have 2 equals 1.022 to the power t. Very easy to find t. Apply ln, so you have ln 2 equal t comes down, and you have ln of 1.022, and finally t is ln 2 divided by ln 1.022. We claim that this t years, after this t years, we will have the population doubling. Let's check. So we will go back to our formula. Remember, our formula is here, and we just substitute this value for t. So we'll put ln 2 over ln of 1.022, and let's see, equals 1,441,000. It is the double the population, twice of the population. And how many years is this? Let's just find it. What is ln 2 divided by ln 1.022? Just to know the approximately. 32 years approximately. So this here is approximately 32 years. It takes 32 years approximately, or if you want to be precise, 31.85. So 31 years and about 10 months. So yeah, or 32 years for the population to double if it was growing at this rate. And it doesn't matter what we start with, because when you have P0 times a to the t and you want it to be twice of itself, it will always cancel. And you will always have to apply ln, and you'll get ln 2 equals t ln a, and always t will be ln 2 over ln a. Okay, and I will stop here.